In this video, we are going to cover three exponent properties, the first of which we have actually already been using to multiply polynomials, and that is the product property. The product property says we multiply the coefficients and we add the exponents. So in that first example, number 1, we have two monomials being multiplied together, and we treat this as we have been. Multiply the coefficients to get 16 and add the exponents. So m to the 7th, and that's it. For number 6 down here, number 2, missed that. Number 2, remember there's those hidden exponents. Those will be very important, those hidden ones. So again, the coefficient is 2, or 1 times 2 is 2, and then we add the exponent, so v squared. Down here on number 6, again, if you need to help separate those, draw those parentheses in there to help separate the two expressions we're multiplying. And then once again, we are multiplying the coefficients, so we get 6, and then adding the exponents of like basis. So in this case, there is no other a, so it's just a to the third, but then b to the fourth and b to the second, those get added together, and we get b to the sixth. Okay. On the next section, in number 15, let's take a look at that one here real quick. Again, we're multiplying the coefficients, so there's a hidden 1 coefficient for that second term, and so 3 times 1 is 3, and then any variable with a matching variable with exponents we need to add up. So I see a z to the first and a z to the power of 0. Well, that's just z to the first. So I'm just going to hide that 1 again and put z. There's an x to the fourth, but that's the only x term, so x to the fourth. Y to the second, and then there's a y to the first. So that would be y to the third. Now, a lot of times you're probably going to see that written as x to the fourth, y to the third, and then the z, so alphabetical, but those two expressions are the same. Okay, so on to the next property. So the next property we are dealing with is the quotient property, and that has to do with dividing. And when we divide the coefficients and we subtract the exponents. It's the opposite of multiplying, right? So for number 16, we have a quotient, right? So fractions are representing division, quotient. So the coefficients we divide as normal. Well, in this case, 4 over 3 doesn't divide evenly. And then we subtract the exponents. So b to the fourth and b to the first. 4 minus 1 is 3. And that exponent in its base goes in the part of the fraction where the larger exponent was. Okay? So it stays in the part where the larger exponent is. Number 19, again, we divide the coefficients as normal. So there's a hidden 1 coefficient in the denominator. 3 divided by 1 is 3. And then we subtract the exponents. And that would give me an r to the power of 0. Okay? Well, r to the power of 0 is actually just equal to 1. Just 1. Not an exponent, just the number 1. So this is actually saying 3 times 1, which is just 3. No variable term left. Okay. So let's take a look at one more example from the quotient property, and that is number 29. So we are taking a look at dividing, and when we're dividing, we take a look at the coefficients and divide them if we can, which in this case, 1 over 5 does not divide evenly. And then we look at the exponents of the same bases and we subtract them. So 8 minus 2 is 6. That x to the power of 6 goes in the numerator where the larger exponent was. Same for the y's. Y to the power of 8 and y to the power of 3. 8 minus 3 is 5. So y to the power of 5th, to the 5th power. And then same for the z's. 7 minus 4 is 3. Okay, so my final answer, I'll move that 5 over. so it's nice and evened out there. But that's it. That's as far as I can simplify that expression. So the last property is the power property, and that says when we have a power to a power. So if you look at number 31, we have an exponent on the outside of that parentheses. And so that means, if we wanted to expand this, that means we could say 3k squared times 3k squared times 3k squared, right? So that exponent means we write out the base 3 times. And so now that is really just multiplying all that together. So if I multiply all those together, I'm multiplying the coefficients, which would be 3 times 3 is 9, times 3 is 27. And then I add the exponents. So 2 plus 2 plus 2 is k to the 6th. So this expression I started with is equal to 27k to the 6th. Well, the power property tells us there's a shorter way that we can do that. And we can do that simply by taking the exponent on the outside and multiply it to each exponent on the inside. So there is a hidden 1 exponent with the coefficient. So 3 to the power of 1 and k to the power of 2. So if I multiply each of those exponents by 3, I get 3 to the 3rd and k to the 6th. So now what I have left with is I have the k to the 6th, but then I can still evaluate that 3 to the power of 3. So 3 to the power of 3 is where that 27 comes from. Okay? So we can expand. So right here, when I expanded that out to begin with, we can expand it out and multiply as normal, or this property allows us to do that a little bit shorter. So like on number 35. On number 35, that exponent is a 2. So inside the parenthesis, I have a 4 to the power of 1 and an n to the power of 3. So if I multiply each of those exponents, that would give me 4 squared and n to the 6th. But then I notice that I know what 4 squared is. That's 16. So 16 n to the 6th is my final answer. Okay. Let's take a look at another one yet on this page. So right here we have for number 36. For 36, we have a couple things on the inside that have powers of 1 that are hidden. So this 6 on the outside is going to get distributed to each of those terms on the inside. Okay, so 4 to the power of 1, 1 times 6 is 6. So 4 to the power of 6, x to the power of 6. And 6 times 0 is still 0, so y to the power of 0. I'm going to grab a calculator quick. And now, in my calculator, I can take 4 to the power of 6, and that gets me, so right here, 4 to the power of 6 is 4,096, x to the power of 6, and then y to the power of 0 is actually just 1. So if I had a times 1 on the end there, that wouldn't change anything. So that y to the power of 0 effectively cancels itself out. It just equals 1, and since there's other things left over there, we don't need to write that times 1 because then it doesn't change anything. And so that would be my final answer for that one. Let's take a look at 2 more here. Number 39. That 0 exponent does something special, or it kind of behaves a little differently than what you might think. So in this situation, that exponent of 0, again, I can still treat it as this property of distributing that exponent to all of the other exponents, but that's just going to give me x, or 6 to the power of 0, v to the power of 0, and u to the power of 0, right? So each of those exponents gets multiplied by 0, and then that means anything raised to the power of 0, which I have 6 to the power of 0, that's just 1. V to the power of 0, that's just 1. u to the power of 0, that's just 1. 1 times 1 times 1, you guessed it, is 1. Okay? So this is actually another property of exponents that we're not explicitly saying here, but anything raised to the power of 0 is just equal to 1. It doesn't matter what that is. Anything to the power of 0 is just 1, always. Okay? And then the last one we can do here together is number 44. Again, there is a hidden coefficient of 1 here, but we don't really need to worry about that because that hidden coefficient of 1 has a hidden exponent of 1. And even if I were to distribute that 6 to that hidden exponent of 1, all of that's still going to end up turning out to be 1. And so we've just kind of done some redundant work there. So really, all I'm going to do is distribute that 6 to each of those exponents that are there for those variables. So I get x to the 48, y to the 30th, and z to the 24th. And that is it. Again, just to emphasize, these are all things that are being multiplied together. So there's no plus sign in between those. There's no subtraction sign. Those are all being multiplied together. Okay? So at this point, you can go ahead and keep working on this activity, and then you can check your answers with the answer key provided.